Okay, let's continue with the next lecture, and that is about showing you how the data looks like on the UMCG high performance cluster. So as mentioned before, the previously Lifelines data was accessible through Windows workspaces, and there you had SPSS for phenotypic data viewing and analysis. And if you have had genotype data, there was data on about 13,500 individuals that had been genotyped with the cytosnip chip, and those data were already available through the high performance cluster. But since last year, the Lifelines made their data available on the UMCG high performance cluster, which is a Linux cluster, and which you saw already yesterday. And that the reason for this is because the advent of the ugly data, genotype data, new genotype data on about 36,500 samples. With this cluster, the tools for, well, the easy tool for SPSS disappeared because SPSS is not available for Linux. And now you have to use Unix tools if you want to see what the data are look like, the phenotypic data are look like, and use R for your phenotypic data analysis. So in the first, so this morning, I will focus on this part. So the Unix tools for phenotypic data viewing, and in the afternoon I will be discussing R, more about the Unix tools, but also more about R, how to perform data analysis on the cluster. So as mentioned already yesterday, and there is this home directory where you, if you start up MobaXterm, you will end up in your own home directory, which is unique for each user. And the most important thing that this is that this home directory is not for data storage. There is a limit of 2 gigabytes of, it's a soft limit though, but there is a 2 gigabytes limit of storage there, and that is not sufficient for most of the R libraries. So you have to store your install your R libraries in your own project directory. We'll come to that later in the afternoon. And also important thing is you can run jobs from here, but that's not recommended. Also, for if you want to use if you want to run jobs, use the temp and your project folder for that. Then already mentioned the permanent storage, PRM3, which is a high availability file system for permanent data storage, which is backed up regularly. We as users cannot store anything on this. It is write protected for us. So if you want to store anything on there, you have to ask the Lifelines data managers to store data on this. And as Peter mentioned yesterday, it is not for storing, well, intermediate files, or it is mostly, it is meant to store your final data results or analysis results of your scripts, and so the things that you want to use for want to store for longer time. From this permanent storage, you cannot run jobs, and also data that are stored in here cannot be used in jobs. So therefore, there is a clone on the temp directory of your project folder and of the Lifelines data, which is well, a high performance system for temporary data. So all your intermediate data can be stored here, but this is not backed up, and I think they say that it will be cleaned every 90 days, or but so far I haven't seen that any of my files has disappeared or have been deleted. So, but nevertheless, it's good to know that this is not backed up, and it could be that that they clean the files or at some point this directory. There is a write protection on the releases folder, so on the Lifelines phenotype and genotype data, but you can write, of course, in your own project folder. Your jobs can run from here, and data stored in here can be used in jobs. So the releases directory, Sylvia already mentioned this this morning, but I want to show you how it looks like when you use Unix tools. So if you have the releases folder, as mentioned, it's both present on the permanent storage as well as in the temporary storage, and it contains all Lifelines data. And there are two folders for the phenotype data, those that are measured by Lifelines and those that are derived from the data from Lifelines. So this, Sylvia talked about this. Judith Vonk will tell more about the data that are in this restructured folder. So then in the releases of Phenotype Lifelines, there is this V1 first release and the second release. The first release is not available anymore to new users, but in this Phenotype release, they had data files that combine data from multiple visits and multiple assessments, and that was pretty difficult to maintain. And also the variable names, they were, well, difficult to interpret. They were something like health 35. So they made a new release in the beginning of this year, release 2, where the data from the multiple visits are in separate files, as Sylvia showed this morning, and also they gave the variables the meaningful names. So let's, if you want to see what's in the folder V2, you can use the ls or list command to see what files and subfolders are in there. And here you see again what Sylvia also mentioned, the enumerations, the results, the variables. There's also a scripts folder and the important README folder. In the enumerations folder, that contains data coding for categorical data. So it will tell you for a categorical variable what the value of 1 means and what the value of 2 means. Then in the results folder, there is the actual data. And in the variables folder, there is metadata on all the phenotypic variables, saying, for, well, this is the what the variables mean and where they are coming from. And in the scripts folder, there is an R scripts for replacing missing values. As Sylvia mentioned this morning, they have now separate codes indicating whether a Lifelines participant has seen the question but did not answer it, or whether this person did not see the question at all. So then in this subfolder variables, you have the different files. It says for each of the visits. So the one is the baseline visits, and the Q stands for questionnaire data, as Sylvia mentioned this morning. To view what's inside the file, you can use the head command in Unix, and that will show you the first 10 lines of a file. So if I look into the questionnaire data of the first questionnaire on baseline, it will tell you, it will give you this result if you look at the first 10 lines in this file. So it will tell you what's the variable name in the results files, in the other files, enumeration files. The historic variable name, the name that was used in the first release. Well, data type, so that means for instance, for instance, sex is is a string, postal code is a string, then the definition in English, definition in Dutch, and yeah, other things are in there. So so with this file, the variables you can in the files within the folder variables, you can search for your data, what you want to analyze or use in your analysis. So for instance, if I want to have data on hypertension, I can look with the grep command. I can look within all files in the variables folder. So that means this, I want to look in the variable folders, subfolder of the V2 folder. And I want to look in all files. That's what this star means. And I want to search within these files for the term hypertension. And this -I means that I want to, that it's case insensitive. So it can be capitals, it can be small letters. The first letter can be capital, and so on. So if I do this grep command in the V2 folder, well, here I am in the V2 folder, so I don't have to do this V2 anymore. I just want to search for hypertension in all files within the subfolder variables, and I get this this long list. So that will then tell me within this file I see hypertension in this line. It will give you the result, will be the whole line within the file. So it will tell you, this command will tell you, okay, this is a variable for hypertension, the original name, so HEL 35, well, and so on, what's there on hypertension. So you see here that there are 3 variables saying something about hypertension within the baseline questionnaire data. And there are 2 variables within the questionnaire data of the third assessment. So you have hypertension presence, start age of hypertension, and treatment for hypertension. And again, for that's in baseline, and for the third assessment, there is again presence of hypertension and the start age. And maybe there's more, but I only printed the first couple of lines. So this gives you a lot of data already, but the data might be this might be give a long list. If you want to search more specific, for instance, if I want to search only in the baseline data, then I don't specify here the star, but I specify here 1 star, meaning that I want to search in all files starting with a 1. If I want to search only in the measured data or from the baseline visit, I also give in here that I want to search within the baseline visit and only the measured data. Or if I want to say I want to search in all files but not in questionnaire data, then I say I want to search in the baseline data given by 1 star, but exclude data from the questionnaire. So this grep -v means invert your selection. So report exclude the files that have _q_ in their names. So now that we have found, so let's go back here. So now that we have found, for instance, here, this is the variable for presence of hypertension at baseline. So I want to search more information about this. I want to see how this variable is coded in the data. So I found out that this variable was present in the 1AQ1 variables file. So if I want to look for the enumerations, I'll search for it in the 1AQ_Q_1_ enumerations file in the subfolder enumerations. And do it in the same way with this grep commands. So if you do that, then this will be the results, saying that in your results file, the hypertension presence in adults from questionnaire 1 is coded as a 1 to 3 variable, where 1 means, yes, I do have hypertension, 2, I don't have hypertension, and 3, I don't know. Then you want to get the actual data. So you go to the results folder, and here I see this. This should be results. Then you go to results subfolder, and in there is a file 1AQ1 results.csv, so a comma separated file. If I look within this 1AQ1 results file, then you see and this less minus s means that I want to scroll through the file, but only print, truncate the lines onto the screen width. Then you get this results, and there's a lot of data within this file. So the question is now where to find the data on hypertension within this file. So we saw before that we have this, we had results within 2 files, at baseline and at the third assessment on these 3 variables. But this one, for instance, this 1AQ1 results file is a big file with, more than 700 columns. So which columns do I need? And to find out how many columns a file has, you can use this command stating I want to only the first line of a file. So -n1 means only the first line. I replace every comma, because this is a comma separated file. I'll replace every comma with a line end, so it will break up, it will put all the headers not next to each other, but below each other. And then do WC -L for the line, counting the number of lines. So this command applied to this file gives me a result of 772. So there is a lot of data within this file, and you don't want to scroll through all of those 700 lines to find out which line is exactly the one that you need. So how can we decide which are the columns that I need? Well, again, you can extract the header, so you get only the variable names. Replace the commas with an end of line with this set command, and then you can print the line numbers and the column header with this awk command. So if you put that all behind each other, head /set /awk, then you get, and then less to scroll through all those 700 lines, you get this result. So it will tell you project pseudo IDs in column 1, absence past months in adults, presence in line 9. So, but still, then you will get a list of 700, more than 700 rows, 700 lines. So you can add this again for grep -I hypertension. So again, head of the first line from this file, replace the commas by the end of lines, print the line number and the content of the line, and extract only the data for hypertension, and you see that then the data that you are looking for are in these columns 375, 376, and 377. So now that you know which columns of the file you need, you can extract the data with a cut command saying that the delimiter is the comma, and I want to extract the first field or column, so that's the pseudo ID, and then the lines 375 through 377, so that's the lines that we previously identified as containing the hypertension data. And that will then give you this result. The pseudo ID, hypertension presence, hypertension start age, and hypertension treatment. What you see from this file, that everything is in quotes, so everything is stored as a character variable. Also, when you read it in R, everything will be characters, and that's mainly because of this, what Sylvia also mentioned this morning, the coding for missing data. So here is a $6. This person has identified the two for hypertension presence, which meant I don't have hypertension. So then this person doesn't have to answer the question on what's the start age of hypertension, because he doesn't have hypertension, and also not what hypertension treatment he is on. So only when there is a 1, say this individual said, yes, I do have hypertension, then there are values for start age and treatment. And even then it may not be there, because somebody may not know when hypertension started, may have been a long time ago. He cannot recollect the exact date or age. So then this command gives you a result on screen. You can save it to a file by adding this redirection sign and then the file name to your command. So if you do the cut command and then save it to a file, then it will then do this redirection and then indicate a file. Then the results of this command, of this cut command, will be saved to this hypertension baseline file. And here I used this variable, my project there. This is a variable that I created before, saying with the name of the directory of my project. You can get it back, or well, to get the content of this variable, you put this $sign in front of it. So this is how you can make a variable and use such a variable in Unix. Any questions so far? Please take the mic or put it in the chat if you have any questions on this. No, so you will be working with these commands yourself in the practical session. So you can also ask questions there if. So then I want to have here a list of Linux tools that I find very useful in to use in the cluster. Well, some of them have already been passed in the previous slide. So the head command with this -n sign it will show you the first n lines of a file. You can also show the last lines of a file tail with the tail command. So then with the default will be 10 lines, but you can change this again with the -n option. -n2 will show you the last 2 lines of a file. And also very convenient is the less command that allows you to scroll through a file. Press then Q to exit. And also when you are scrolling through a file, you can use the page up and page down or the space bar to scroll through it. Also, you can search for something in the file. If you press the slash, the forward slash, and then type your search term, you can search for a particular text within the file. And another convenient thing is this option -S. That will truncate long files to the screen width. If you don't put this -S, then it will wrap the lines on screen. But if you put this -S, then every line will also be with one line in the screen, but the lines will be truncated. Then the cut command, it will show you particular columns from a file. So if you say, for instance, cut -F1 of a file, it will show you the first column of a file. If the default is a tab delimited, so if you don't specify what the delimiter is, then it will assume that the file is tab delimited. So if a file is actually a comma separated, then this -F1 will just give you all columns because you didn't specify the space, the delimiter of the file. So one will show you the first column. You can also 1-10. It will give you the first 10 columns, or you put commas in between. 3, 5, 8. It will show you columns 3, 5, and 8. Or you can combine these. 1, 3, 5-7 will show you 1, 3, 5, 6, and 7 column. Or you can put a dash without anything, then it will show you columns 10 and further. And as I said, use the -D to set the delimiter, because the tab is the default. So if you want to use a white space as delimiter, then you use this -D quote space and end quote. To count the number of lines within a file, you can use the WC -L of a file, so word count, but word count and then -L means only the number of lines. So if you, for instance, would do this, then this is kind of weird. You can just put WCEL -L here in front, and then this then it will give you how many individuals or how many rows are there in this line, in this file, plus and that usually is number of individuals plus the number of header lines. If you want to count the number of columns, as I mentioned before, you do it with a concatenated command, saying first take the header, then replace the delimiter, so let's say the comma, by end of lines, and then count the number of instances. So the number of, this would actually again count the number of lines, but now we have transformed converted the header line from columns to rows with this set command. Or alternatively, you can, this is only counting the number of columns, assuming that every row has the same number of columns. If you don't know this and want to find out if all the columns are the same, then you can use this awk command, saying print number of rows, of a number of the row, and number of fields or number of columns within this row. Then if you want to combine data from multiple files, then you can, with the cut command, you append, in this case, file 2 to file 1. So it will put it below each other and it will save the results to a third file. If you want to combine merge columns, then you can use the paste command. So then it will put all the files next to each other. But this assumes that, well, if you have data from individuals, then it will assume that these files are sorted. It will just paste them together. It will not look into the order of the files or whatever. So you have to be careful with this one. You can then better use the join command if you want to merge them based on a key. For instance, this pseudo ID, and then you give in well, let's say that for the first file, the key is in the first column, and for the second file, the key is in the third column. Then it will merge them based on these keys within the two files, and again save it to a third file. But the one thing that you need to make sure then of these two files is that these files have to be sorted based on the key. And you can sort them using this command with the sort command, saying, let's say I want to sort them based on the third column, minus K3. And I want to sort file 1 and save the result in file 2. If you have numeric data, then you add the option minus n. So then it would be sort minus n minus K3 file 1, redirect to file 2. Another nice thing command in Unix is the set command, where you can replace text by another text. So text 1, replace it by text 2 throughout the file. That's what this minus g, this slash g means, throughout the file. So here you can, then this command says I want to replace within this file text 1 by text 2, save the result to another file. If you add the option minus I, then this file 1 will be overwritten. So this could be convenient, but you have to be sure that you are doing the right thing. And another useful tool is the grep command. I already also showed it. That extracts all lines that contain from file 1 that contain pattern in their lines. The result will be the whole line. There are different options that are convenient. So the minus W is to match whole words. The minus V is to exclude lines that contain a pattern. So that's the inverse actually. And the minus I option for case insensitive matching. If you want, this will search for the pattern within the whole line. It doesn't matter whether it's in the first or in the second or in the last column. If you want to search for a pattern in a particular column, then you can better use the awk command, and then it will and then do an if command. If the first column, this means the $1 means first column. If the first column is equal to pattern, then print it, and then it will extract all the lines that contain pattern in the first column. You can, and with awk, you can do a lot of things. You can do very complicated things to extract things from the file or add new columns to files to the file. So for instance, here it's a little bit more complicated. This, when I add this nr equal to 1, means I want to extract all the I want to extract the first line, or this means or, so these double vertical slashes. If the pattern, the first column is equal to pattern, then print it. This command will extract the header plus all the lines that contain pattern in column 1. Are there any questions on this? Unix tools. No, I don't think so. Okay, so that's what about the theory. So now I will introduce you to the exercises of this morning. So in these exercises, you will first set up a directory structure within your project folder. View the Lifelines phenotype data on the releases folder, and prepare input files for data analysis that you will be using later today in the second practical session. For these exercises, we will focus on the outcomes of hypertension and blood pressure, an independent variable of body mass index, and adjust for age and sex. To go to, for the exercises, you need data from Nestor. So go to the course website on Nestor, to content, and then day 2. And there will be files with the exercises, the answers, input files, data, scripts. If you have downloaded them, then go to MobaXterm and log into GearShift, and then look at the reader with the exercises to start with the exercises. In case that you have a question, you can put it in the chat, either use the chat for everyone or the chat to me in particular. And if needed, then you can share your screen if I add you to a separate breakout group. So any questions on the exercises? Well, so far. I think not. I think you're all eager to start with the exercises, so please go ahead with the practicals, and I will be here waiting for your questions, and my chat or in a breakout group. Okay, good luck.